In this video, we'll take a look at Cramer's rule. The problem is to find the value of z given the following system of equations. Well, Cramer's rule tells us that the value of z is the ratio of two determinants. It's the determinant of az over the determinant of a, where a just represents the coefficient matrix of the system. So we're talking about the determinant of 2, negative 3, 5, 3, 4, 1, 5, 3, minus 1, just pulling the coefficients out of the system. Now the determinant of az represents the determinant of the following matrix. We're going to copy down A, but we're going to replace the column for z, meaning the third column, with the constants that appear in the system. So instead of writing out the coefficients of z, we're writing out 21, 14, and 9 in that last column. Notice that we were not asked to find the values of x and y in the system. Cramer's rule is particularly useful when we just need to solve for one or a few of the variables in the system. As a side note here, if we had been asked to find, say, the value of x, then we could say, well, x is equal to the determinant of ax over determinant of a. And to figure out how to define the matrix AX, we can look back at what we did down here. To get AZ, we replaced the Z column of A with the constants. So to get AX, we would replace the X column of A with the constants. And to finish up this discussion, I'll say y is equal to the determinant of AY over the determinant of A. To get this matrix AY, we would replace the Y column of A with the constants. Now at this point, I'm going to erase our side note and we can get on with our determinant calculations. Let's calculate the determinant of A by cofactor expansion along the first row of A. Well, each term is going to look like a signed entry times a 2 by 2 determinant. And the sign is dictated by this checkerboard pattern for the sign. So you've always got a plus in the upper left-hand corner, and then the signs alternate as we move down or to the right. So there's our checkerboard pattern. All right, so starting with the 2, we're taking positive 2 times the 2 by 2 determinant that remains when we cross out that row and column. And we're just going to continue that process along the top row. So we move over to the negative 3. The sign associated with that position is negative, so it actually becomes a plus 3 times the 2 by 2 determinant that remains when we cross out this row and this column. We've got 3, 1, 5, negative 1. And finally, finishing up with that first row there, we've got a plus 5 times the 2 by 2 determinant, 3, 4, 5, 3. So finishing off our calculation, this is equal to 2 times negative 7 plus 3 times negative 8 plus 5 times, we've got 9 and minus 20, so that gives us negative 11. All right, so negative 14 minus 24 minus 55 gives us negative 93 for the determinant of A. Now let's calculate the determinant of AZ. Just for the sake of showing you both methods, I think we could use the quick formula for 3 by 3 determinant for this part of the calculation. So the way that works, I'm going to copy out the matrix AZ, and I'm going to recopy the first 2 columns. And we're going to be forming these products along these diagonals here. So as we do that, 2 times 4 times 9, that gives us 72. Multiplying along that line there, the product is negative 210. And multiplying along this this line here, 21 times 3 times 3, that gives us 189. All right, so that's half the calculation. We also need to calculate products along the backwards diagonal. And each of these products is multiplied by a factor of -1. So you could think of it as subtracting off these products if you like. I prefer to just build the negative sign in so that we don't have sign errors there. So along this first backwards diagonal, it's looking like 5 times 4 times 21 times -1. That gives us -420. And along the other two diagonals here, the products are -84. And watching our signs here, 9 times 3 times -3 times -1, that's +81. Alright, so determinant of AZ is then just the sum. We add up these 6 numbers, so -420, -84, plus, just adding up all these numbers up to 189. That gives us -372. So there we have our two determinants. We'll be able to finish the problem in a minute. So I chose to calculate determinant of A by cofactor expansion. You may have expanded along another row or another column. That would be fine. You may have used the quick method to calculate this determinant. As long as you're getting the answer -93, all is good. Similarly, down here for the determinant of AZ, you might have chosen cofactor expansion instead. Again, as long as you're getting the answer -372, then you're fine. So to go back to Cramer's rule then, we said Z was going to be the ratio of these two quantities. So the value of Z is -372 divided by -93. Z is equal to 4, and that is our final answer.